Hello again, everyone, and thanks for tuning in. Videos are a couple of days late. I apologize. But today we'll talk about independent and dependent relationships. We did a little demonstration in class where everybody stood up and I had everybody make basically like a big X with their bodies. And I said, if somebody tried to push you, you wouldn't fall down if you were making a big X with your body because you're strong, your legs are strong, your arms are giving you balance, so you are not going anywhere, okay? On the other hand, if you are a Y, making a Y with your body, now I'm not an artist, as you can tell, and I put one leg down, and I keep one leg up, obviously it's going to be pretty hard for me to stand up by myself. So here's just a silly way to help you remember that X is our independent and Y is our dependent. It needs something to stand up straight, like a chair, a wall, a person, something like that. So keep that in mind as we go through this video. Okay, so independent and dependent relationships work a lot in algebra as they do in science. So you shouldn't get confused if your science teacher ever uses these terms. It kind of works the same. When we talk about it, we're usually talking in terms of X and Y, input, output, domain range, those kind of things. And your science teacher is talking a little bit more along these terms, but it's not that much different. So what I have here is a glass of water, okay, some lemons, and as you can see, lemonade. So what we're going to do is we're going to categorize these according to independent, dependent, all of that. Okay, so I start out with a glass of water. This is what is about to change. And so I'm going to add in the lemon juice, the lemons, whatever it is. So when I add the lemons to the water, the lemons are my independent because they are changing the water. So the result, this lemonade over here, is my dependent because I guess you could say the flavor of it depends on how much lemon I put in. So whatever is depending on something else is the dependent, and the thing that changes that to be what it's going to be is our independent. Okay, now let's get to the real nitty-gritty kind of correct use of terms. So what we generally say is that Y depends on X. The kind of relationship that they have is an input-output relationship. So if you think about a table, I have X and Y. Say I have the equation Y equals 2X. In order for us to get an output Y, I need X. So that's why X is called the independent. Say I plug -1 into this equation. I would get 2 times -1, and that equals -2. If I plug 0 in as my independent variable, then I get 2 times 0 is equal to 0. I can choose anything. I can choose 10. 2 times 10 is equal to 20. Okay, here is a word problem with independent-dependent relationships. Sue hikes at an average rate of 4 miles per hour. The number of miles M she hikes is viewed as a function of the number of hours H she hikes. Describe the relationship using independent and dependent variables. I didn't mean to make this miles seem like I marked it out. I was actually trying to underline my important information while going through this big amount of words, which is what you should always do when you're faced with a word problem, because sometimes we can get overwhelmed by the amount of words, so feel free to mark all over your paper. Okay, so what is important here, I circled our variables because one of them is going to end up being our independent, and one of them is going to end up being our dependent. I don't know yet. So this is M and this is H. Okay, notice the wording of the question. It says right here, the number of miles M she hikes is viewed as a function of the number of hours H. So if the number of miles is viewed as a function, if you're really comfortable with function notation, then I could write this: the function of hours is equal to the rate, which is 4, times the number of hours. And this f of h would actually mean miles, because it said miles is viewed as a function of h, and they told us at the very beginning it's 4 miles per hour. If that doesn't make sense to you, then just think about it using just plain logic. So I know that her rate is 4 miles per hour. In order for me to know how many miles she has gone, then I have to know how many hours that she's been going. So in that case, that makes my miles M dependent on the hours. So M would be our dependent variable, and H would be our independent variable. Okay? Alright, last example. So what we have here is a table representing time and balance. So this time we're going to say that's in years. Okay, so let's interpret this table just a little bit. So it looks like time is going. We have 0 years, 1 year, 2 year, 3 years. And over here, balance is actually decreasing. 2,000, 1,500, 1,000, 500. So maybe it's a bank account that we began with 2,000 and we're taking out after so long. We're not adding in any kind of money, which is not really good. But so in this case, you should notice that this table here kind of looks like a regular table that we see, X, Y. So time is always changing. I can't change time. And obviously it is changing whatever the balance is. So if I go to year 3, it's gone down so much since year 0. And if I keep going, it's going to keep going at this same rate. So for this example, time would be our independent and balance would be our dependent. Alright, that's all I have. Hope you tune in next time. Have a good day.